In this video, I'm going to show you how to build a powerful but dead simple analytics agent that you can run in your terminal and ask it questions about your data, any scale. To do this, we're going to use the Vercel AI SDK inside of a single file Node.js script and hook that up to Tinybird using the Tinybird MCP Server. With this approach, we'll get a scalable, flexible, and highly capable AI analyst that can tell us what we want to know about our data. You ready? Let's go. Now, to set up the data infrastructure for our analytics agent, we're using Tinybird. If you don't have one already, you need to create a free Tinybird account and a cloud workspace. So I'm going to go ahead and log into this workspace that I already have based on the Ghost Analytics template. And you can see it has about 500,000 web analytics events in it. That's about 30 megabytes of storage, which is well within the free tier limit of 10 gigs. Okay, we've got the data. Let's create the agent. So I'm going to create a file called CLI.js and open it up in Cursor. First, we're going to set up the interactive CLI interface, and we're going to use the readline module. So let's go ahead and import readline, and then we'll create the readline interface to accept standard in as input and output to standard out. It's very easy. Now let's create a function that initializes our MCP client and connects to the Tinybird MCP server. So we'll start by defining a null MCP client variable, and then we'll create this async function. And because I work with Tinybird MCP server a lot, Cursor's reading my mind, and it already knows that URL, which is mcp.tinybird.co plus a token parameter. Now, this is important. This token is a Tinybird token that gives scoped access to the resources in your Tinybird workspace. Whatever permissions that token has, the MCP server will share. Now, depending on your use case, you may want to create a dedicated MCP token with custom permissions, or even use custom JWTs with row-level security policies. You can learn more about Tinybird tokens and how they work with the MCP server in the docs. They are linked below. So let's go ahead and get a token from our Tinybird workspace. And since I'm just creating this for myself, I'm going to use the workspace admin token from Tinybird, which gives me full read-write access to the workspace. So I'm going to add that token into my environment variables file. And yes, I will rotate this token immediately after I record this. So got the token, and we can create the MCP client from the URL. And we're going to use the experimental create MCP client function from the AI SDK. And since the Tinybird MCP server supports streamable HTTP protocol, we'll need to import that protocol specifically from the MCP SDK. So I'll set that as the transport protocol for the MCP server and provide the URL. And then I'm going to set a unique session ID for each connection. And that should create our MCP connection. And assuming it works, we'll go ahead and log a success message to the console. So then let's get the tools from the MCP client and list them out to the console as well. And finally, we will return them from the function so that we can hand them off to our agent. And of course, Cursor adds some basic error handling for me as well, which is great. Okay, so we have a function to connect to the MCP server from the CLI. Let's go ahead and create a main function that we'll call start CLI. We'll first output a little welcome message to the console, and then let's go ahead and get those tools from the MCP client by calling that function. And then of course, we'll call that main function from the script. Let's go ahead and run this and see if we can connect to the MCP server. So I'll head over to my terminal and run this script with the environment variables, and great. Our CLI connected to the Tinybird MCP server and listed out all the available tools. Now, let's talk about this tool list, because the Tinybird MCP server is doing some very heavy lifting here, and it's going to make all the difference in our agent's ability to analyze the data effectively. First of all, you'll see this Explore Data tool. This is actually a server-side agent that our agent can pass a question to ask anything about the data, no matter how ambiguous. For example, it might ask the Explore Data tool to analyze all of our data and figure out all the different unique path names we have in our blog. The Explore Data tool can use a multi-step process on the MCP server to go and get that answer, rather than attempting a single text-to-SQL generation that might fail. That's a really powerful tool that our agent can use. The MCP server exposes other core tools. One of them is text-to-SQL, and this is also important because this tool is yet another server-side agent that understands the underlying schema of all the data you have stored in. It also uses a specific LLM model that excels at SQL generation, and it is tuned to write optimized queries using the ClickHouse SQL syntax that Tinybird supports. So Rather than force our agent to write its own SQL without understanding any of the underlying data context, we can use that server-side agent to render the SQL for us and then execute it. There are also other tools here, of course, to execute a SQL query and then also list various resources. And then you'll notice a bunch of other tools below that. And these are the API endpoints that you create in Tinybird. So in Tinybird, you can publish any SQL query as a dynamic parameterized API endpoint, and these get added dynamically as tools to the MCP server. And this is really useful because it lets you define deterministic access patterns. LLMs are notoriously non-deterministic, and they can give varying answers to the same question every time you ask. Setting up these API tools means that for common analytics questions, the agent can simply fetch the data from the API, supply query parameters as needed, and get a deterministic response much more efficiently. This is great for both reducing token usage and getting consistent results for known query patterns. You can learn more about the Tinybird MCP server and all the available tools in the MCP Server docs, which of course are linked below. Okie doke, we have our MCP tools. Now let's give them to agent. So I'm going to create a function to accept the user input, pass it to the LLM, equip the LLM with those MCP tools, and then parse the output. First, let's create an empty array to store the chat history. This is a simple and somewhat naive way of maintaining context for each subsequent request. Now, for a production scenario, we would want to add some kind of compaction or summarization to this. But for now, we're just going to maintain the entire message history as context, and we will eat the token usage. So let's create this ask question function that accepts the user question and MCP tools as parameters. So when a user asks a question, we will push that question to the chat history array. And now let's get a result from the LLM. We're going to use the stream text function from the AI SDK, which will stream the output from the LLM to wherever we want it to go, in this case, standard out. So let's go ahead and add that to our imports along with our model provider. And I'm just going to use Anthropic here. All right, let's head back down and configure the stream text function. And sure, I'll just tab this in. So we're going to use a Claude Sonnet model, add the full chat history as messages, add these MCP tools that we passed in the arguments, a couple other things here, and then we need to define a system prompt. Now look, at least half the battle in creating good agents is good prompting. This is not a prompt engineering tutorial, but I'll share my current system prompt. Let me just paste that in and title the word wrap so that you can read it. Okay, so I am explicitly telling the agent to use Tinybird MCP tools, and I give it some specific instructions not to generate its own SQL, but rather use those MCP tools. I'm also telling it to limit the default time range for any queries or requests to the last 24 hours. This helps prevent querying more data than I need to by default and using a lot of compute resource. I'm also hard coding my site UUID for my blog so the agent can pass that as a query parameter to the various APIs. And finally, I'm telling it what today's date is so that it knows how to handle questions that mention relative time ranges. Could this be improved? Sure, but it's a good starting point. And like I said, this is not a prompt engineering course. So once we initialize the agent, we'll log a little thinking message and create a blank string to store the full text response. And then we'll start handling that stream text result. And the way the stream text function works in the AI SDK is it will output little text chunks or deltas. So we can await those deltas and handle them as they arrive. Now, deltas can have different types, and we want to handle how we render the output based on the different types. For example, for a tool call, we will log the tool name and the arguments passed to the tool. There are a bunch of other things we could log here, and maybe we could render this a little more cleanly, but this will get the job done. We could also show the tool result. I'm not going to worry about that for now because parsing and making it look pretty can be a little bit tricky depending on the tool. It's a lot of logic, and we just don't need to handle that right now. Maybe we can come back to that later, but for now, we're just going to break here. And then we have text start, which just signals the beginning of an LLM text output. So I'm just going to log an empty line to make some space. And then we have the text delta type. And this is a chunk of the text response from the LLM. So we're just going to stream that to standard out, and then we are also going to append it to the full response. And finally, we will handle the finish type by logging a completion message. And then just in case, we'll handle any other types by default with a break just to suppress any unwanted output. And then once we've handled all the deltas, we'll print out a little line and push that full agent response to the chat history to maintain that context. So let's head down to the start CLI function so we can call this question function. We're going to add a little self-calling arrow function that will create a prompt using the readline question input and wait for the user input and pass it to the ask question function along with those MCP tools. We'll await the response, and then after the response is complete, we'll log a new line and call the function again to start that process all over again until the user exits. And of course, we need to call that function, and to round things out, we'll add a little Control-C handler to kill the agent process when a user wants to quit. That's it. 124 lines of code. Okay, let's try this out. But first, I need to add my Anthropic API key. So I'm just going to paste that in. And yes, I will delete it after I record this. So let's try it. All right, let's run the agent. And we're going to ask it a simple question like, how many rows of data in the analytics events data source? And it will go and figure that out. And in this case, it's using the explore data tool, which is a bit inefficient. But I did tell it not to write its own SQL, so it's using the tools it was instructed to use rather than write a SQL query. And this took a little bit too long for my liking, but I did get my answer, and it is correct. I have 500,000 rows in that data source. Now, I probably could have let the agent generate its own SQL here. So I'm going to go update my system prompt to give the agent permission to generate its own simple SQL queries and otherwise use the tools from the Tinybird MCP server, and let's see if it makes a difference. So let's go ahead and restart the agent, and then we'll ask that question again. Okay, this time it's using text to SQL, so it's still not attempting to generate its own query. That's fine. I can continue to tweak the system prompt to be more specific in the future. And again, I get my answer, 500,000 rows. Now, let's ask it to tell me what my top performing blog post was in the last 30 days. And this time it's using that API, that top pages tool, and it's using query parameters that match my 30 days request. And there's my answer. My Hello World blog is the top performer. Also lets me know that my homepage has the most visits along with a couple other blog posts that are performing well. Now, because we're maintaining the chat history, let's just ask it what the top source is for that blog without mentioning the blog specifically. So first it's trying to call the top sources API, but it looks like it missed a filter parameter. So of course now it's trying to generate its own SQL query, but that probably didn't work. So it's just going to fall back to that explore data tool and ask the server side agent, which will think for a bit, and then there we go. We get the top sources for that blog post with a little analysis from the agent. Pretty cool. We just built a simple but flexible analytics agent that runs in our terminal using the Vercel AI SDK and the Tinybird MCP server. It's all less than 125 lines of code. We can improve this a lot with better system prompting, and we can add a bunch more features to make this agent more robust. But this is a good foundation for building real-time analytics agents that we can task with analyzing data for us. If you want to learn more about building agentic experiences with data, I'd encourage you to check out the links to the Tinybird documentation below. They are super useful. And by the way, if you're just getting started with Tinybird, it is free to sign up, and I would encourage you to try Tinybird Code, which is our own CLI agent for building projects in Tinybird. It's kind of like Claude Code, but it is optimized for building highly performant real-time analytics pipelines in Tinybird. Good luck.